Hello, students. How are you all? I hope everyone is doing well. In our previous classes, we have discussed about current electricity, exercise 8b numericals. In today's class, we are going to solve exercise 8b numerical from question number 26 to 31 in a simple and easy way. So, let's get start. Today's first question. A cell supplies a current of 1.2 ampere through two resistors, each of 2 ohm, connected in parallel. When resistors are connected in series, it supplies a current of zero point 0.4 ampere. Calculate the internal resistance and EMF of the cell. So here the two resistors given, each one is 2 ohms and connected parallel to each other. The current flows through the circuit is 1.2 amperes. What we need to find the internal resistance and EMF of the cell. When the two resistors are equal, then I will find the equivalent resistance when connected in parallel. So this is the first. Okay. Then 1 by R equivalent equal to 1 by 2 plus 1 by 2 will get 2 by 2. So 2 to get cancelled. R equivalent equal to 1 ohm. There is an internal resistance in the circuit. So I will write here the total resistance equal to 1 plus internal resistance. Then electromotive force equal to I of the total resistance 1 plus R. If I will draw the circuit, I will get it like here. So this is one resistor, other, both are connected parallel to each other. Cell, internal resistance. This is the circuit. Here the current flows. This is 2 ohms, 2 ohms, internal resistance, electromotive force. Current given 1.2 ampere. 1.2 amperes given. So epsilon equal to current 1.2, resistance 1 we found equivalent when they are connected in parallel to each other. 1 plus R is the internal resistance, and then this is the equation 1. Now, if both are arranged in series, see the circuit first. This is 2 ohms, 2 ohms. Internal resistance R, electromotive force sigma, epsilon, and how much current flows through? 0 0.4 ampere. Current is 0 0.4 ampere. The, the total resistance will write here RT equal to plus 2, 2 plus 2 plus R. Then total resistance is 4 plus R. Total. Then epsilon equal to I of the total resistance 4 plus R. Epsilon equal to current 0 0.4, 4 plus R. Equation 2. Equate the equation 1 and 2. Equation 1 equal to equation 2. So equation 1, 1.2, 1.2 of 1 plus R equal to 0.4 of 4 plus R. 4 plus R. Then 0.41 ja, 0.43 ja. We have a equation 3 of 1 plus R equal to 4 plus R. 3 plus 3R equal to 4 plus R. Then we'll get 3R minus R equal to 4 minus 3. 4 R equal to 1 by 2 equal to 0.5 ohms. This is the internal resistance. This R value, substitute any one of the equation, either 1 and 2. I will take from the equation 1. Then epsilon equal to 1.2 of 1 plus internal we found 0.5. Then epsilon equal to 1.2 to 1.5 multiplied, you will get 1.8 volt. Get 1.8 volt. 1.8. This is the electromotive force. We found it. Question number 27. A battery of EMF 15 volt and internal resistance 3 ohms is connected to two resistors 3 ohm and 6 ohms connected in parallel. Find the current through the battery, the potential difference between the terminals of the battery, the current in 3 ohm resistor, the current in 6 ohm resistor. So what is given in the question first? So this is the epsilon, electromotive force of the cell. This is the internal resistance, smaller, and these two are 3 ohms and 6 ohms are the external resistance. They are connected in parallel. First, I would like to find the equivalent resistance between 3 ohms and 6 ohms. They connected in parallel. So 1 by R equivalent, 1 by R equivalent equal to 1 by 3 plus 1 by 6, that equal to 2 plus 1 by 6, 3 by 6, 3 by 6. Then you will get here R equivalent equal to 3 1 ja, 3 2 ja, 2 ohms connected in parallel. Then I'll find out total resistance in the circuit. So RT equal to external resistance we found 2, internal given 3, and total resistance T equal to 5 ohms. And then electromotive force given. We'll find the current by using the Ohm's law. Electromotive force epsilon equal to I RT, total resistance. Epsilon 15 equal to I into This is a 5. 5 1 ja, 5 3 ja. So I equal to 3 amperes. I equal to 3 amperes. Now potential difference between the terminals of the battery. Here we have, first I will find here voltage drop. Small v equal to capital I, small r, internal resistance. So small v equal to current 3 and internal resistance 3. That implies voltage drop we will get here 9 volt. For the closed circuit, epsilon equal to, main electromotive force equal to terminal voltage plus voltage drop. Then terminal voltage equal to electromotive force minus voltage drop. Then V equal to, given 15 electromotive force, voltage drop we found 9. Then what will you get here? V equal to 6 volt. The current in 3 ohm resistance. I will draw the circuit, then I will get the idea. I mean, we will get the idea. One resistor. This is the other one. This end is connected to the positive terminal of the battery, negative terminal, and this is the internal resistance. Circuit is over. Now this is 3 ohm resistor, 3 ohm, 6 ohm, and this is 3 ohm. Battery is 15 volt. Current flows from higher potential to lower potential, and we found it is 3 amperes. Here, this is the point we can call junction. So A and B, we can call junction points. At junction, I will write the current. I will write here I equal to I1 plus I2. This is the junction. Then how can we define it? How can we get the statement for the junction law? Some of the current coming towards a point equal to the same current moving away from that point. So here the total current we found it is 3 amperes. So 3 equal to I1 plus I2. So consider this is the first equation. At A and B the potential is same. When potential is same, we will write here V equal to I1 R1 equal to I2 R2. So which is the I1 here? This is the branch. This is the other branch where the current I1 passes. This is the current I2 passes. Then I will write here I1 is I1 as it is because unknown it is. Resistance is 3 ohms equal to I2 as it is. The resistance is 6 ohms. Here will get cancelled, 3 1 ja, 3 2 ja. So finally we have I1 equal to 2 I2. Then I will use the equation 1. From equation 1 we will write D equal to, in place of I1 I will write 2 I2 plus I2. Then finally we have 3 equal to 3 I2. Then I2 is 1 ampere. 1 ampere. Then what will you get the I1? I1 equal to 3 minus 1. So I1 equal to 2 amperes. Superb. We will go with the next one. The circuit diagram in figure 8.53 shows three resistors 2 ohms, 4 ohms, and R ohms connected to a battery of EMF 2 volt and internal resistance 3 ohms. If main current of 0.25 ampere flows through the circuit, find the potential difference across the 4 ohm resistor, the potential difference across the internal resistance of the cell, the potential difference across the R ohms or 2 ohms resistor, and the value of R. The value of R. So this is connected in parallel. It is okay. Here the current enters, divided into I1, I2, and then again it can merge. I mean combine. Then we can get here the current passes I. I mean I is given 0.25 amperes. So potential difference across 4 ohm resistance. We will write here the first one A B equal to I R, Ohm's law. Then B equal to current is given 0.25 amperes into 4 ohm resistance. V equal to what will you get? V equal to 1 volt will you get. This is the first one. The second one, the potential difference across the internal resistor. I mean we need to find the voltage drop here. B equal to I mean option B equal to voltage drop small v equal to I into small r. Small v equal to I is 0.25 internal resistance R T. Then V equal to 0.75 volt. This is the voltage drop. Voltage drop it is. Now the potential difference across of R ohms and 2 ohms are any one enough. So here given we need to find the potential difference across R are 2 ohms. Okay, before that we use here Ohm's law. I mean junction law we can use. Some of the current coming towards a point equals some of the current moving away from that point. This is the point here. I will take it is a P point. This is the Q point. At P, how much current is entered? I will write C. It is A equal to P equal to like I1 I1 R1 capital R, not small r, capital R it is equal to I2 R2. Then I1 as it is resistance 2 equal to this is coming again. Then I2 here, I1, I2, and this is capital R as it is. It is capital R it is. Okay. Then we do not solve it because there are three unknowns here. Before that, I will find here the equivalent resistance when they are connected in parallel, and then I will find the total resistance in the given circuit. So I will go with the next page. So here this 3 ohms internal resistance and this is the external 4 ohms are connected in series. Series we know that is 7 ohms. Before that I will find the equivalent here. 1 by R equivalent equal to 1 by 2 plus 1 by R, that equal to R plus 2 by 2R. R equivalent equal to 2R by R plus 2. Therefore, the total resistance I will write now. The RT is the total resistance. There are 7 ohms. 7 plus 2R by R plus 2. Then RT equal to, I will take LCM, 7R plus 7 to the 14 plus 2R whole divided by R plus 2. Then the total resistance RT can be written as 9R plus 14 by 2. Okay, using Ohm's law for electromotive force, like it is epsilon equal to I RT. Epsilon given in the circuit? What is given epsilon? Epsilon given 2 volt. So it is 2. Current is 0.25. It is 0.25. 0.25. RT is 9 R plus 14 by 2. Then I will do the cancellation here. 0.251 ja and then 8 ja it is. So finally we have a equation 8 equal to 9R plus 14 by 2. 16 equal to 9R. 16 equal to, here I left the R. 9 is R plus 2, right? R plus 2, yes, R plus 2 it is. I miss here R plus 2 it is. R plus 2. Then I will get 16 plus 8R. 16 plus 8R I will get. So this is 2. 16 plus 8R equal to 9R plus 14. Then you will get 16 minus 14 equal to 9R minus 8R. Then 2 equal to R. So finally we found the external resistance in parallel is 2 ohms. Then the current can be divided equally it is. So this unknown resistance is in the one connected in parallel equal to 2 ohms. Then depend upon the resistance, the current can be passes through it. But both are the same resistance. Then the current equally divided here. So answer you will get for the current is, for C, I mean the potential difference I will write here. V, I mean you will get the current I1 equal to I2 equal to it is 0.125 amperes. Therefore the voltage, the potential difference you will get here V equal to 2 into, I mean here the 2 is our resistance and the current is 0.125. So finally voltage you will get V equal to 0.25 volt. The value of R we found already, that is 2 ohms. The next question. Three resistors of 6 ohm, 2 ohm and 4 ohm are joined to an ammeter A and a cell of EMF 6 volt. I show in the figure. Calculate the effective resistance of the circuit and the reading of the ammeter. Okay, look at the diagram. In the diagram, these two are in series. 6, 4 plus 2, 6, and 6, these 6 parallel to each other. Then I will find the equivalent resistance first. 1 by R equivalent equal to 1 by 6 plus 1 by 6, that is 2 by 6. R equivalent equal to 3 ohms. 1 ja, 2, 3 ja. So finally R equivalent equal 3 ohms. And there is no resistance of ammeter, internal, I mean internal resistance of the battery. So directly we can use here the electromotive force epsilon equal to current we don't know, so I resistance is equivalent 6 volt. 6 volt equal to I into 3. Therefore, the ammeter reads 2 ampere of current. Ammeter reads 2 ampere of current. The next one, the diagram below in figure 8.55 shows the arrangement of 5 different resistances connected to a battery of EMF 1.8 volt. Calculate the total resistance of the circuit and the reading of the ammeter. First, I would like to find equivalent resistance between R1 and R2. These two are connected. I mean, these two are connected in parallel to each other. And the next, I will find R3, R4, R5. These three are arranged in parallel. After the resultant of these two are in series. Okay. First, I will find the equivalent resistance between 1 and 2. So 1 by R equivalent equal to 1 by 10 plus 1 by 40. What will you get here? 4 plus 1 by 40, that equal to 5 by 40. Then R equivalent you will get here 8 ohms. Similarly, between 3, 4 and 5, R equivalent equal to 1 by 30 plus 1 by 20 plus 1 by 60. LCM is a 60, so it multiplies by 2, multiplies by 3 and plus 1 by 60 by 60. Okay, that implies 1 by R equivalent equal to 6 by 60. 6 1 ja, 6 10 ja. So you will get here R equivalent equal to 10 ohms. Total resistance in the circuit RT equal to 8 plus 10 equal to 18 ohms. Electromotive force given 1.8 volt. I need to find the current. So epsilon equal to I RT. Total resistance 1.8 equal to I into 18. So we will get cancel. 18 1 ja, 18 0.1 ja is therefore current in the circuit I equal to 0.1 ampere. This is the current. The next one, SL of EMF 2 volt and internal resistance 1.2 ohms is connected to an ammeter of resistance 0.8 ohms and two resistors of 4.5 ohms and 9 ohms. So in the figure 8.53, the reading of the ammeter, the potential difference across the terminals of the cell, the potential difference across 4.5 ohms. Okay, before I'm going to find anything, I need to find the resistance, total resistance 1.2 here, 1.2, and this is 0.8, and then 2, 4.5 and 9. Both are arranged parallel to each other. Then I will find here one, it is equivalent resistance first, 1 by or equivalent equal to 1 by 4.5 plus 1 by 9, that equal to 2 plus 1 by 9 equal to by 9 ja 3 3 ja. Finally we have R equivalent equal to 3 ohms. Total resistance RT equal to internal resistance 1.2, ammeter is 0.8, external resistance we found 3. So total resistance in the circuit is 5 ohms. Now we'll use the Ohm's law. Epsilon equal to I RT. Total resistance. Voltage epsilon is given to I into 5. Then I equal to 2 by 5. We get I equal to 0.4 amperes. The current you will get it. Meter read 0.4 ampere of current. The next one, the potential difference across the terminals of the cell. We need to find here terminal voltage. For closed circuit, we have epsilon equal to voltage drop, terminal voltage plus voltage drop. This is given to equal to V, capital V, plus current we found 0.4. The resistance, internal resistance is 1.2. Multiply into 1.2. Then V equal to 2 minus 12 4 48, 2 decimal points, so 0.48 you will get. Then V equal to 2 minus, okay, I will subtract here. I will subtract 2 minus 0.48, get 1.52 volt. This is the B it is, and this is the A. What we need to find the next one, the potential difference across the 4.5 ohms. Okay, this is the here. There are 2 points here. I will select in the circuit. This is the Q here, P and Q. The current flows here in this direction, that we found I current. Here the current can be split depend upon the resistance. Let us take in the above branch I one current passes, in below branch I2 current passes. At junction law, we will write the current. It is I equal to I1 plus I2. Similarly, the potential is same between anyway. I mean, above branch or below branch, potential is same. So I will write here V equal to I1 R1 equal to I2 R2. Then V equal to I1. I don't know here what is I1, but R1 I know 4.5. I2 I don't know, and R2 is 9. 4.5 1 ja, and then this is 2 ja. So finally we have I1 equal to I2. We found the current 0.4 ampere, the total current. Then the total current is 0.4 equal to 3 I2 it is finally. I mean I1 plus I2, that is 2 I2 plus I2, 3 I2. Then I2 you will get here 0.4 by 3 amperes. Therefore, what we need to find the potential now. So V equal to what is the current here? Resistance 9. Current is we found 0.4 by 3. 3 1 ja, 3 1 ja, 3 3 ja. Then V equal to 3 into 0.4 to get 1.2 volt. So this is the potential across 4.5 ohm resistor. Thank you. In the coming class, we are going to solve current electricity exercise C.